So coming down to number 34 in the book. If y'all want to pause and read, and we'll come right back. Okay, to approximate the distance across a river, a surveyor chooses a point P on the edge of a river that he's on, and he also chooses a tree that's on the edge of the other side of the river, directly across from him. The surveyor then chooses the third point R on the same side of the river as point P, so on his side. Okay, using his surveying equipment, he finds point R is 220 feet from P, and that certain angle is 109.10, the other angle is 42.20. Okay, what is the distance from point P to point Q? Alright, you've got P, Q is directly opposite U, and then you've got R on your side, and R is 220 feet from U. Okay, let's draw ourselves a picture. Okay, so if we call this P right here, we'll call this, let's see, we get there Q, and then down there, maybe the same side, so maybe we'll make that R. Definitely don't want to draw a right triangle though. That won't work out so well. Alright, I could be wrong. I might have to come back in here and edit this a little bit, but this is kind of my initial guts just to try this out, okay? So let me pull up the problem again and let's see what kind of information we can get. Alright, we know that he finds that point R is 220 feet from point P. So R is 220 feet from point P. And then he gives us a couple angles here. Angle QPR is 109.10. So QPR, that angle right there, should be 109 degrees in 10 minutes. And the other angle, so PRQ, is 42.20. So PRQ is 42 degrees in 20 minutes. And then we just have to find the distance from P to Q. Okay, not too bad. First of all, let's just find that last angle inside. This last angle right there, if we call that alpha, we know that alpha is going to be 180 degrees minus the other two angles. Okay, and if we plug that into our calculator, we're going to get 28 degrees. And let's see, 60, 50, 40, 30, and 30 minutes. Okay, so there's alpha. So if we go in here to solve the problem with what we want to know, I want to find x. So x over the sine of the angle opposite that, which is 42 degrees and 20 minutes, should equal another side that we know. The only one we do know is 220 over the sine of the angle opposite that, which is 28 degrees and 30 minutes. Okay, so x is going to be 220 times the sine of 42 degrees 20 minutes over the sine of 28 degrees and 30 minutes. Alright, let's plug this into our calculator, and looks like we're probably going to round to 3 significant digits on this one too. And if I round, then I get roughly 310.5. I don't know, I can debate this all the time. Why don't we just go 311? We'll call it feet. Alright, box that up. Let's go to our last problem, number 38 in the book. Alright, here we have points P and Q are in the same horizontal plane with the base of a mountain. From P, the angle of elevation of the top of the mountain is 4550. Q, which is a lot closer towards the base of the mountain from P, the angle of elevation is 5040. How high is the top of the mountain above the horizontal plane that contains points P and Q? Alright, we got P, we got Q. Alright, let's draw ourselves a picture. Flat road, mountain. We'll put there points P. We'll put there point Q. 1,111 feet directly closer. Looking up to the top of the mountain from P, we have an angle of elevation of 45 degrees and 50 minutes. And looking again to the top of the mountain, from point Q, we have an angle of elevation of 50 degrees and 40 minutes. Okay? So we can do several, what all we want to do with this to solve this problem. Here's the top of the mountain up there. First of all, they want us to find, if we go back to the problem real quick, it says, how high is the top of this mountain above the horizontal plane that contains points P and Q? Okay, so they're not asking for this side. They're asking for basically this right here. How high is it from the horizontal plane that has both points P and Q? So we're looking for this right here. Do y'all kind of remember doing a problem just like this way back when we were learning the whole SOHCAHTOA, because it's kind of a right triangle? Okay. It's kind of similar to that one, but we're eventually going to get there. So I don't need this one line in here. Let me erase that one just for a second. Okay. Less things make it less confusing for us. All right. What I'm going to do here is I'm actually going to do a combination of old stuff and a combination of new stuff. Because if I can get this right here, this side right here, then all I have to do is use this formula. Remember, with respect, since I'm in a right triangle right here, we're going to take that fact and really utilize this. With respect to our angle 50 degrees and 40 minutes right here, X is the side opposite and Y would be the hypotenuse. So opposite over hypotenuse is sine. So sine of 50 degrees and 40 minutes is going to be the side opposite, which is X, over the hypotenuse Y. So if I can get that hypotenuse Y through this other triangle that's like over here, right in here, that's not a right triangle, so if I can use something from this chapter to find this what Y is, then I can plug it in and we'll be done with the problem. Okay, so let's do all this other work here for a second and we'll come back to this. Okay, so I know a side, it's 111 or 1111 over the sine of the angle opposite that, which would be up here, let's call it alpha, is going to equal another side, which is the one we want to find, which is Y, and the angle opposite Y is the 4550. Okay, so if I can get alpha, then all I have left to do is solve for Y, plug it in up in the top right, and we're done. How am I going to get alpha? Okay, 2 seconds here. We have a straight line. Half of it's 50/40. What's the other half? Well, it's got to add up to 180. So if we call that theta, then I can say theta is equal to 180 minus 50 degrees and 40 minutes. So doing the math real quick, changing 180 to 179.60. If you do 179 minus 50, you'll get 129. And 60 minus 40 is 20 degrees. Okay, so that's what theta is. I know 4550. I know 129.20. So alpha, come over here, alpha is going to be 180 degrees. The three angles of the interior of a triangle have to add up to 180. So 180 minus the two other angles that I know. And doing the math real quick, alpha comes out to be, let's see, 4 degrees and 60 minus 10 and 50 minutes. All right, so we're going to plug that in right there. So Y is going to be 1,111 times the sine of 45 degrees and 50 minutes all over the sine of alpha, which is 4 degrees and 50 minutes. So Y equals 9,458 feet. Okay, kind of large, but if that's 111, Y is a very, very, very large side. So I'm thinking we're pretty still okay. Okay, let's take that and plug it back into our original problem we're looking to solve for that Y right there. So it says that X basically is my Y value times the sine of 50/40. So it's the 9,458 times the sine of 50 degrees and 40 minutes. And we get our final answer of 7,000 316 feet. And there is the height of the mountain. Guess what, guys? We are finished. Yay, the very, very last problem for this whole entire class. So now it's all about study, 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 and keep our fingers crossed and hope the final exam goes wonderful.